law of sines, but now we're going to go over the ambiguous case.
Yeah.
So that's when you have two sides and an angle within your triangle. Okay, so we have two sides and an angle within the triangle. So if you are given the measures of two angles and a side, exactly one triangle is possible. However, if you are given the measures of two sides and the angle opposite one of them, 0, 1, or 2 triangles may be possible. This is known as the ambiguous case. So when solving a triangle using side-side angle case, 0, 1, or 2 solutions are possible. So to check to see if you have 1, 2, or 0 solutions, first thing you're going to do is look at your angle that you're given. So if that angle is acute, you first need to check to see if A, so the side opposite the angle given, is less than the height of your triangle. Okay, if it's less than the height of your triangle, you have no solutions. If your side opposite your angle is equal to the height of your triangle, you have one solution. Okay, if the side opposite your angle, so again A, is greater than your height and less than the other side you were given, you have two solutions and you have to find both. That's a fun one. Okay, or if you have your side opposite your angle greater than or equal to the other side you're given, you have one solution. Okay, so you have two possible ways to have one solution, one for no solution, and one for two solutions. Now that's if your angle is acute.
All obtuse, just no solution.
Now if your angle is right or obtuse, okay, so it could be a right angle, meaning it's 90 degrees. You need to look at your side opposite the angle you're given, which is A. If it's less than the other side that you're given, you have no solutions. Okay, the other one, if that side opposite your angle is greater than the other side you're given, you have one solution. Okay, so if you have a right or obtuse angle, you can't have two solutions. You either have no solutions or one solution. So if you see an obtuse, it can either be one solution or not. So since sine of angle A is equal to h over b, you can use h is equal to b times the sine of A to find h. So when you have an acute triangle, you do need to find h for these three cases here. Okay, so you need to find this h value, which is your height, in order to see if it's no solution, one solution, or two solutions. So in the following examples, we want to determine whether each triangle has no solution, one solution, or two solutions. Then solve the triangle. Okay, so round your side lengths to the nearest tenth and angle measures to the nearest degree. Okay, so if we get a decimal for our degree measure, we're just going to round it to the nearest degree. So in example 1, we have triangle RST. So I'm going to draw this triangle. Doesn't matter how you draw it, just a triangle. Label it R, S, and T. Okay, we have angle R here, that's your capital, that's 95 degrees. Lowercase r is the side opposite angle R, that's 10. And lowercase s is opposite angle S, that's 12. Okay, so the first thing I want to do is identify whether the angle I'm given is acute or obtuse. Okay, so angle R in this one would be what? Obtuse. Okay, so since angle R is obtuse, that means I'm looking at these two cases right here, whether it's no solution or one solution. So again, your A value in these cases is the side opposite the angle you're given. Okay, so the side opposite the angle I'm given is 10. So that would be A in those two cases up on top. So is 10 less than or equal to the other side you're given? Side B in this case is 12. So is 10 less than or equal to 12?
Yes.
Yes. Okay, so since 10 is less than or equal to 12, and I was checking this case here, this one would be no solution. Okay, so if I did check the other case, that one solution case, again, your opposite side to that angle is A. This one would be 10 again. And I'd have to see if 10 is greater than the other side I'm given. Okay, that doesn't work. So this one is no solution and not one solution. Don't worry about it. You can put an X there instead. I don't know, whatever you want. Okay, does that make sense for that first one?
Yes, sir.
All right, then on the back, number 2, we're going to do the same thing. So this time we're given triangle MNP. So again, I'm going to draw out this triangle. MNP. Okay, this time I'm given angle N. That one is 32 degrees. Lowercase n, so the side opposite angle N is 7. And lowercase p, the side opposite angle P is 4. Alright, so again, first thing I want to do is decide whether the angle I'm given is acute or obtuse. Okay, angle N is acute. It's less than 90 degrees. So since it's acute, that means I'm using the chart to the left that was on the front. So this one here. And I have to check these cases. So in this first case here, this no solution one, I do need to figure out what h is. That's the height. Okay, so my first step here is to find the height. Okay, so I want to find the height. To find the height, we're going to use this equation right here. So h is equal to b times the sine of a. So we're using a as the angle that we were given. We're only given one angle. And we're going to multiply it by the side that's not across from that angle. Okay, so h is equal to the side not across from our angle given is 4. Multiply by the sine of the angle that you're given. Okay, so I'm just using that equation from the front. So our height, or h, once you plug that into your calculator, is about 2.12. Okay, our next step is to find the number of solutions. So again, I'm going to use the chart from the front. So again, our A value in that chart is the side opposite the angle. So the side opposite our angle is 7. Okay, so I'm going to see if 7 is less than our H value. Okay, so is 7 less than 2.12? No. Okay, so that's not the case we're using. Next one is A equal to H. So again, A is the side opposite the angle we're given. So again, 7. is that equal to 2.12? No. Okay, the next case here, our A value of 7, is it greater than H and also less than the other side I was given, so side P, which is 4. So 7 greater than 2.2 and less than 4? No. Okay, then the last case I have to check is where 7, so our A value, is greater than or equal to the other side that I was given, our B value or our P value, which is 4.
Yes.
Okay, so that one is true. So that means we have one solution. Okay, so since we have one solution, to solve our triangle then, that's our step 3. Solve the triangle using the law of sines. So we're just going to use law of sines like we did yesterday. Okay, so that's sine of A over lowercase a equals sine of B over lowercase b. So first what I want to do is find one of my missing angles. Okay, the angle that I want to find is the one that's opposite the other side we're given. Okay, so I'm going to use uppercase P and lowercase p in law of sines. And I have to use uppercase N and its opposite side as well. So I'm going to take sine of 32 over its opposite side, which is 7. That's equal to, since I have this side here of 4, I'm going to find angle P first. So I'm going to take sine of angle P over its opposite side, which is 4. So that I only have one variable within my problem. And just like yesterday, we're going to cross multiply. Okay, so here if I cross multiply, I have 4 times the sine of 32 is equal to 7 times the sine of angle P. Now I want sine of P by itself. So I'm going to divide both sides by 7. So I have 4 times the sine of 32 over 7 equals the sine of angle P. Do you remember how to get an angle by itself? You take the inverse of both sides. Okay, so I'm going to bring in this sine inverse to both sides. That way on the right hand side here, my sines cancel out and I'd have P by itself. Okay, so I have P is equal to the sine inverse of this whole quantity, 4 times the sine of 32 over 7. And that's what you would want to enter into your calculator. Okay, so make sure you are able to enter that in your calculator. You do end up getting angle P to be 17.63. And if I round that to the nearest degree, what would that be? 18. So angle P is 18 degrees. Now if I know angle P is 18 degrees, how do I find angle M? Subtract.
Which is like 130.
130. Okay, I'm almost done. What else do I have to find? Between N and P. So I need to solve for lowercase m. Okay, so I'm solving this triangle. You have to find all the angles and all the sides. So just like we did, we used law of sines, okay, before, we're going to use law of sines again to figure out that last remaining side. So how should I set that one up?
We don't.
You don't?
Yeah, we don't.
Yeah, you do.
How we just don't?
Okay, that's equal to what? 130. Okay, that's what we did yesterday. We solved for a side using law of sines. Okay, so take the angle you're given, sine of the angle you're given over its opposite side, equal to sine of the other angle over the side you're trying to find. Okay, cross multiply. So we have 7 times the sine of 130 is equal to m times the sine of 32. Get m by itself. Divide by sine of 32 on both sides. Plug this part into your calculator. Okay, so 7 times the sine of 130 divided by the sine of 32. I got 10.1.
Sure.
All right, questions?
Yeah.
Can we not do the next one? Is that what you just said? It's longer. All right, so again, first thing you want to do is find your angle, whether it's acute or obtuse. Then if it's acute, you have to find h, or the height. Then find your number of solutions, and then you can solve using law of sines. Okay, so that's what we're going to do in the next one here. Okay, I want you to do the first 2 steps. So find the height, because you have to, it's acute. Find the height, and find the number of solutions. And then I'll go through the rest. Don't write super big. Warning you in advance. You're going to run out of room if you write too big. Set this problem up. Find h and find how many solutions there are using that chart from the front of your note sheet. Find the height. Use your formula to find height. And on the front too. We can highlight it if you want. This is your formula to find height. So I highlighted blue there. What? You're finding h. What? Yes.
No solution. Go ahead. Dinger.
It does have solutions.
No, it doesn't.
Yeah, it does.
That's my book.
It has 2.
No. Oh, no, it's got no solution.
It's got 2.
Oh, this one right here. H.
Yeah, it's
Which solution?
the fun one, apparently.
Fun one.
No.
Oh, duh, that is 2 solutions, okay. I thought. Yeah.
Oh my gosh. Bruh. Long. I found out what it is.
That'll show you a good time.
It's the only one that has 2 solutions.
It's the only one that has no solution.
What do we have to do after that? Or like 13.2.
I'm just making sure it's what I'm going. I don't want to get the.
That's lost.
All right, so you should have drawn your picture. Angle A is acute. Okay, it's less than 90 degrees. Then step 1 is to find the height. Okay, so your height formula was given on the front. It's B times the sine of angle A. So you have 18 times the sine of 47. You end up with 13.2 as the height. Your next step then is to find the number of solutions. So we're using, again, that chart from the front. So you want to see if your side opposite your angle, so letter A, 15, is less than H. So is 15 less than your H value that you found? No. Okay, then is your A value 15 equal to the H value you found? No. Okay, then next I have my A value of 15. Is it greater than the H value I found and less than my B value? That one is true. So there are 2 solutions.
Awesome.
Okay, so my next step, step 3, is to solve my triangle. Okay? So for step 3, solve triangle using the law of sines. And in step 3, you're going to have 2 cases because you have 2 solutions. Okay, so case 1. Is where angle B is acute. Yes, it is. Not like a road sign. Okay, so where angle B is acute, I'm just going to redraw a smaller triangle here like we had up top there. So we have A, B, and C. And we want to solve this triangle using law of sines just like we did in the example above. So we're going to do the same process that we just did in the example above. So I'm going to use sine of the angle I'm given over its opposite side. That's sine of 47 over its opposite side of 15 is equal to sine of angle B over 18. Since I want to first find that angle that I'm missing with its opposite side. Okay, so from here, again, we cross multiply to solve. So we have 15 times the sine of angle B is equal to 18 times the sine of 47. Divide both sides by 15. To get sine of angle B is equal to 18 times the sine of 47 over 15. Okay, what's my next step to solve? The negative thing, an inverse. Bring in sine inverse to both sides. Okay, then I can plug in sine inverse of that entire quantity to get that angle measure for B. And round to the nearest degree. Okay, so no decimals. What would be the nearest degree for that one? What? I got 61. Okay, so if angle B is 61 degrees, how do I find angle C?
Subtract 47 and 61.
Good. So to get angle C, subtract 47 and 61 from 180. $72 degrees. Okay, last step for this one, this case. Find lowercase c using law of sines. So I'm going to take sine of, again, angle A, since it's the one I didn't round for, over its opposite side. So sine of 47 over 15. Where are you looking? Oh, that's the height. 13.2 was the height. We don't use the height for law of sines. Just to see our different cases. Okay, then sine of angle C is 72 over its opposite side of C. Okay, cross multiply. We have C times the sine of 47 equals 15 times sine of 72. Divide both sides by sine of 47. So they cancel here. This is what you'd want to plug into your calculator then. Okay, on the right hand side there. Point what?
0.5.
Yes. Okay, so that was case 1. Okay. Yeah, that was case 1. Case 2 doesn't take as long once you do case 1.
I thought we were over, so I don't have the note.
I told you to write
I
small.
did write a small count.
Okay, so step 3, I'm going to continue up here on my note sheet so I have more room. So I told you it's a lot.
Oh, just give us more room.
I gave you as much room as I could because you needed room for the other problem. Okay, so case 2, this is where angle B is going to be obtuse instead of acute. Okay, so it's going to be greater than 90. So since sine has a positive value in quadrant 2, to find the obtuse angle, all you need to do, okay, to find the measure of angle B is take 180, because quadrant 1 and 2 together make 180, they make a straight line. Subtract the acute angle that you found from case 1 for angle B. What was case 1? Angle B was what? 61. So subtract 61 from 180. So angle B would equal what?
119.
119.
Agreed.
Okay, so now if I have angle B, how do I find angle C?
You're right. 180 minus 2.
No, don't do that.
19.
180 minus 119 minus 47. Again, it's a triangle, right? Angle B is just obtuse now. Okay, angle B was 119. Angle A is still 47. So again, just subtract those two from 180 to get angle C. $14. Huh? You're missing a side. So angle C is 14. We have side A, that's 15. Side B is 18. But we're still missing this lowercase c side right here. So I just have to do law of sines once in this case. Okay, so I need to take sine of A, which is 47, over its opposite side. It's equal to sine of angle C over its opposite side. Okay, cross multiply. And divide by sine of 47. Is it 0.1?
No, it's just. Maybe.
Is it 5.08 something?
No, it's 4.
It's for what?
4 or 5 minutes. 1.5. I got it wrong.
That's not what I. Oh yeah, you're probably right. Okay, 5.0. Yeah.
Yeah.
So you do have to find, when you have two solutions like this, you have to find the missing two angles and the last side in case 1, and the missing two angles and that missing side again in case 2. Okay? And in case 2, it's pretty easy to find that missing angle again. Since quadrant 1 and 2 form a straight line, you could just take 180 minus the angle B you already found for that obtuse angle. Okay? Okay, questions?
Are we done yet?
Yeah.